Have you ever tried to dig a hole at the beach, right where the waves wash in? The water keeps collapsing the sand, and you can never get very deep. For hundreds of years, connecting Great Britain and France with a permanent link was one of engineering's greatest dreams. Digging a ferry across the English Channel worked, but stormy weather often made the journey slow, difficult, and unreliable. So what about a bridge? A bridge that long would need hundreds of massive support pillars, creating a dangerous obstacle course for one of the busiest shipping lanes in the world. The most brilliant, and by far the most difficult, solution was to ignore the surface completely and travel underneath the seabed itself. But how do you even begin to attempt something like that? The first huge problem is the water pressure. An entire ocean is sitting on top of you. That weight creates a crushing force that could implode any simple structure instantly. This meant you couldn't just dig a hole. You would have to build the strong, permanent tunnel lining at the very same moment you were digging. The next massive challenge was the ground itself. What would you even be digging through down there in the dark? Before any digging started, geologists spent years creating a detailed map of the seabed between England and France. They drilled hundreds of core samples, pulling up long cylinders of rock to understand every single layer beneath the ocean floor. Deep down, they found something amazing. A special, continuous layer of rock called chalk marl. This specific layer was perfect. It was soft enough for a machine to dig through, but also strong and waterproof, which would help prevent catastrophic leaks. It was like nature had created a secret pathway just for the tunnel, a geological road waiting to be followed. Now for the main events. You've found your path, but what kind of machine can dig and build a tunnel at the same time, all while working under an ocean? You can't just use dynamite and shovels. It would be dangerously imprecise and risk flooding the entire project in seconds. The answer was a piece of mega engineering called a tunnel boring machine, or TBM. Don't think of it as a drill. Think of it as a moving factory, as long as a football field and as wide as a 3-story building. At the very front is the cutter head, a giant rotating disc covered with dozens of incredibly hard steel cutters. As this massive disc spins, it grinds away at the chalk marl, chewing through the rock face meter by meter. But what happens to all that crushed rock? It has to go somewhere. The cutter head has special openings that scoop up the ground-up rock, feeding it onto a long conveyor belt. This conveyor belt runs along the entire length of the TBM, carrying the waste material, called spoil, all the way to the back. There, small trains would meet the TBM, load up with tons of spoil, and carry it all the way out of the tunnel back to the surface. A set of powerful robotic arms inside the TBM picks up huge, curved segments of pre-made concrete. The arms carefully place these segments against the newly dug earth, bolting them together to form a complete, waterproof ring. Once a full ring is built, the entire TBM pushes off it using immensely powerful hydraulic jacks, thrusting itself forward to start digging the next section. It was a constant, slow-moving cycle. Dig, build the ring, and push forward. Over and over again, 24 hours a day. This created another huge problem. How do you steer a machine that's hundreds of meters long when you're deep underground with no way to see outside? The answer was lasers. Each TBM was guided by an incredibly precise navigation system. A laser beam was projected from the start of the tunnel all the way to a target sensor on the machine. The TBM's operator just had to watch a computer screen and make tiny adjustments to keep the massive machine perfectly aligned with that dot of light. And their accuracy had to be flawless. Remember, teams were starting from 2 different countries, digging towards each other. If their navigation was off by even a small amount, they would miss each other completely in the middle of the channel. The project wasn't just for one tunnel, but 3 separate ones, all being dug at the same time. There was one main tunnel for trains heading from France to England, a second main tunnel for trains going in the opposite direction from England to France, and nestled between them a smaller service tunnel for maintenance crews, and as a crucial escape route in case of an emergency. A total of 11 massive TBMs were built for the project. Some started digging from the English coast, while others started from the French coast. For 3 long years, over 13,000 workers and their giant machines slowly chewed their way toward the historic meeting point. They battled against unexpected floods when they hit pockets of high-pressure water, dealt with equipment failures, and managed the stress of working deep beneath the ocean. Finally, the moment of truth arrived. The French and English digging teams were just a few meters apart. The last section wasn't dug by the giant machines. Instead, workers carefully dug the final passage by hand. On December 1st, 1990, an English and a French worker broke through the final layer of rock and shook hands, connecting their two nations for the first time in history. The great insight behind the Channel Tunnel wasn't just a single invention. It was a complex system of brilliant solutions working in perfect harmony. It was geology finding the path, mechanical engineering creating the digger, and computer science providing the eyes to navigate it. The tunnel boring machine is the true hero of this story, a machine that embodies the very essence of purpose-built engineering. Building the Channel Tunnel shows us how humanity tackles seemingly impossible challenges by breaking one giant problem down into thousands of smaller solvable ones. The finished tunnel is far more than just a convenient way to travel. It stands as a 50-kilometer-long monument to planning, problem-solving, and collaboration. It's proof that with science, engineering, and enough determination, we don't just find ways around our biggest obstacles. Sometimes we can dig right through them.